Now let's talk about the circular function. The circular functions are defined such that their domains are sets of numbers that correspond to the measures in radian units of the angle. So we will let B an angle in standard position and P theta equal to Pxy, the point on its terminal side on the unit circle. So we will refresh about SOHCAHTOA. So SOHCAHTOA stands for sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Now, if this is our angle here, theta, so this is the y and this is the x, and this is the point of with the coordinates x, y. Now we are here um in a unit circle. So this is the hypotenuse of the triangle, which is equal to the radius. And since this is a unit circle, this is equal to 1. Take note, there is a triangle formed here with 90 degrees. Okay, so if you remember in your junior high school, the SOHCAHTOA. So that's sine is equal to opposite over hypotenuse, which is h here. So the opposite is y over the hypotenuse is 1. So sine theta is equal to 1. Cosine theta is the adjacent, which is the x over the hypotenuse, which is 1. So cosine theta is x over 1 or the x. Tangent theta is equal to opposite over adjacent. So that's y over x. Cosecant theta is the reciprocal of sine theta, which is y over 1, so 1 over y. Secant theta is the reciprocal of cosine theta, which is x over 1, so 1 over x. And cotangent theta is the reciprocal of the tangent, y over x. So that's cotangent theta is x over y. Now we will find the values of cosine 135 degrees, tangent 135 degrees, sine negative 60 degrees, and secant negative 60 degrees by using the standard position. So we start at the positive x-axis. So this is 135 degrees. So take note, there is here is the angle is 45 degrees. Since the straight line is 180 degrees minus 135 degrees, that's 45 degrees. So in short, we can form a triangle under this one with an angle 45 degrees and 45 degrees. And there's a perpendicular angle here in our triangle. So this is a special right triangle with angle 45 degrees and 45 degrees. If we are going to solve this one using the Pythagorean theorem, which is a squared plus b squared is equal to c squared, where c squared is equal to the hypotenuse of the triangle. Now, it is also equal to the a standard equation of our circle, which is x squared plus y squared is equal to r squared. Now our r in a unit circle is 1. So r squared is equal to 1. Now our angle here is the same. So this is an isosceles right triangle. Therefore, the sides are also the same. Now the x and y are the same. So we could use y is also equal to x. So x is x squared plus y squared, which is also x. So x squared is equal to the radius, which is 1. So 1 squared is equal to 1. So 2x squared is equal to 1. Let's divide it by 2. So x squared is equal to 1/2. Let's extract this. Our x is equal to plus minus 1 over square root of 2. So since the denominator is has a radical sign, so this is an improper fraction. So to make it a proper fraction. Let's multiply 2 here, square root of 2, or the denominator of this fraction. So that's equal to x is equal to plus minus. So 1 times square root of 2 is the square root of 2 over the square root of 2 times square root of 2. That's the square root of 2 squared. So that's 2. So that's the answer. X is equal to plus minus square root of 2 over 2. So for mathematician, it is better to have a radical sign in the numerator than in having it in the denominator. So if you have radical sign in the denominator, you rationalize the equation. Okay, so the x is plus minus square root of 2 over 2, which is also equal to the y. So the y is also plus minus square root of 2 over 2. Notice that our angle is in the second quadrant. Therefore, the x there is negative, so we will choose negative square root of 2 over 2, while the y is positive, so we will choose positive square root of 2 over 2. So this is the values for 135 degrees. So how about this one, negative 60 degrees? So of course, negative 60 is from the initial side, starting from the positive x-axis, and then ang rotation is clockwise, so that's creating 60 degrees in angle. So you can also observe that you can form another special right triangle kasi dito yung perpendicular. So that's 60, 90, and then this is 30 degrees. Total of 180 degrees an interior angle of the triangle. Now, according to Pythagorean theorem, if our angle is 30, 60, 90 special right triangle, that also means that the shortest leg of the triangle is half of the hypotenuse. So the hypotenuse here is 1. So 1 times 1 half is 1 half. So our x, or the smallest leg here in our triangle, is equal to 1 half. So if our x is equal to 1 half and our radius is equal to 1, we can determine, of course, our y. So y squared is equal to r squared minus x squared. So y squared is equal to r squared, which is 1 minus 1 half squared. So 1 half squared is equal to 1/4. So that's 1/4. So y squared is equal to 1 minus 1/4 is 3/4. So let's extract both sides. So our y is equal to 3 square root of 3 over 4. Actually, plus minus square root of 3 over, 2. Square root of 4 is 2. So plus minus square root of 3 over 2, which is the y. Since our angle is located in the quadrant 4, so the x here is positive, which is 1 half, and of course the y is negative, so we choose negative square root of 3 over 2. So we have the angle for negative 60, that's 1 half, and negative square root of 3 over 2. We will continue this to another video.